A very good morning to all participants present here. I would really request you can please mute your mic. Please mute your mics. Just. अरे तपन तुमको बोला पंखा चलाने को. A very good morning to all the participants, and I'm really thankful to Harikishan sir for giving me this opportunity to interact with you all and give my presentation. Thank you so much, Harikishan sir. And I'm also very thankful to the ATAL people who have given this chance to do research, learning, and training in such pandemic times also. And we are all stuck up at home, and this gives us an opportunity to work, learn, and train ourselves in new fields. Thank you so much, Harikishan sir. Thank you. So we'll start for today. I'll be talking about artificial intelligence, AI, deep learning, machine learning, and data sciences. These are the terms which are used frequently. I'm switching off my video so that the bandwidth is saved. And in between, I will be switching on so that we can have a discussion. AI, data sciences, deep learning, machine learning. These are the terms which are used frequently, and we fail to understand the exact difference between all these terms. But if we talk in terms of computer science and engineering, these are quite different from each other. AI, as the term, stands for artificial intelligence. So it's basically you are trying to induce intelligence artificially. Human beings are considered to be very intelligent naturally. They have their intelligence naturally. By birth, they are intelligent. We don't have to induce anything artificially to it. Giving you an example, a 6-month-old kid is able to recognize the faces of his parents, even a 6-month-old kid. So did you tell him how to recognize, how to do it? No, the kid naturally understood the face. So, and if you try to write a face recognition problem, if you try to code a face recognition problem, it would be a very, very lengthy code comprising of lines, hundreds and lines of code. But a small kid, even of 6 months old or a 4-month-old kid, is able to recognize his parents. If anyone else takes him in his laps, he starts crying. So what I want to tell you is, like, there is a huge difference between the intelligence of the machines and the intelligence of the human beings. Human beings are intelligent naturally. Now, if I want a machine also to behave the same way as human beings do, it's nothing but artificial intelligence. We are trying to make the machines as intelligent as human beings are. At any point of time, if you feel any problem regarding the audio or anything, if you're not able to see the slides, just let me know. Currently, I am not sharing the slides. So at any point of time, if you have any problems, any questions that you need to discuss, just let me know. You put it onto the chat box. You need not unmute your mic. You can put it onto the chat box. I'm sorry, I'm having a bad throat, so it may happen that I get a cough in between. So I'm really sorry for it, and I would ask you to forbid me for that. So we were talking about artificial intelligence. So as I told you, human beings are intelligent naturally, and if I want a machine also to behave as human beings are, then we have to introduce intelligence induce intelligence into the human beings artificially. Also, we learn from our past experiences. Like suppose food ordering, Swiggy. Okay, you order food from Swiggy. Just after half an hour before, I also ordered food from Swiggy. Okay, so you ordered food. I ordered idli sambar. Okay, and you ordered idli sambar from Venkateshwara Hotel. It was very good. I loved it. Next time also, if I want to order, I'll try to order from Venkateshwara itself because my experience was good with that. Okay, even if I have to try with someone, suppose I had ordered it from Tanjore and Tanjore Hotel, and the taste was not good. So next time onwards, I'm not going to order it from Tanjore. That is, I'm learning from my experiences. So am I intelligent? So yes, I am intelligent. I am intelligent. I'm able to learn from my experiences, my past experiences. And machines also, and we want our machines also to behave the same way. Learn from its experiences, introduce intelligence as we do have. And the second point also, if I say you are intelligent, so are you specific to a particular domain? Do you have intelligence only in one particular field? Like you know about Bollywood, you know about Tollywood, you know about history, who was Prithviraj Chauhan, who was Akbar, who was Babur, you know everything. If I ask you where is Niagara Falls, you would be able to tell me it is in Niagara, USA. If I ask you where is Statue of Liberty, that also you can answer it is in New York. If I ask you where is Colosseum, you would be able to tell me it is in Rome, Italy. So there are many things which you know for geography, for history. Who was Prithviraj Chauhan? Do you know the Battle of Haldighati, the Battle of Panipat? That also you know. Okay, and if I ask you what is your uncle's name, you will be able to tell me that also. So our knowledge is very wide. We know the things of many domains. So we are not domain specific. It's not that only in one particular domain we are intelligent. We know the things about other domains as well. What I want is my machine should also be not domain specific and quite intelligent as we are. Okay. So continuing with the same part, it says artificial intelligence comprises of two words, and it is which is made by human or natural thing. And intelligence means ability to understand or think. If we are able to think what is good, what is bad for ourselves, then it becomes intelligence. Whenever you are crossing the road, you always look to the left, to the right, to the left, to the right, until and unless there is no traffic. And you continue doing it. So this is intelligence. Okay, you are intelligent and you do it not because you were taught. In fact, you were taught also, but as and when you grow further, it becomes unconsciously you do it. It's not that you have to do it consciously always. Like you have to travel onto the left-hand side of the road. You do it unconsciously. Whenever you go out of the house, you lock the door. That is unconscious. And many a times you also feel after coming downstairs, that is, did I actually lock the door? Because that has become your daily routine. Unconsciously you do all these things. Subconsciously, I would say, not unconsciously, but subconsciously you do it. So I want my machine also to be so intelligent that at one point of time it starts doing it on its own, and it doesn't require any software to tell it to do so and so things, or it doesn't require any human interaction in that case. So this makes AI is a branch of computer science because it requires computational methods to actually evaluate and do the things as human beings do. IBM has come up with a very beautiful concept of augmented intelligence. It says that many times it had started coming into the picture, like people have started debating, like if you want a machine to behave in the same way as human beings do, then it may happen that in the near future, the human beings are replaced by machines and the jobs of the human beings are gone, and the machines have started doing the jobs of the human beings. People have started debating such these things. So IBM said that no, it's not possible that the human beings are replaced by the machines. It's only that we are augmenting the intelligence of the human beings. Human Humans are intelligent. Humans are intelligent on their own. Why not add something to their intelligence? We add something to the intelligence. That is augmentation. We are adding to its intelligence. Like suppose if I make an automatic car, so I'm not replacing the driver with a robot. I'm not doing that. The person is driving the car. It's only thing that it may get certain more extra advantages, saying that it can tell you that okay, a car is coming from the back or a car is coming from the front and you should take care of it, or apply the brakes because a car is appearing very close to you. Okay, so such things can be done. So I am just saying that in fact IBM came up with the concept and said that it's augmented intelligence, and don't say it is artificial intelligence. So it says augmented. You add something to whatever it's already there. It's there and you add to it. Augmented intelligence. As I was telling you that we are intelligent in many domains. We know about Bollywood, we know about history, we know about geography, we know about science, we know what is evaporation, what is condensation, and many things we do know from different domains. And apart from that, you also know that who is your neighbor, where is your neighbor working, yeah, what is the name of your uncle, what is the name of your grandfather, what are the choices of your uncle, because if some the uncle comes to the dinner, then you would be able to make the things of his choice. So you are so intelligent. You know everything. You know everything in all the domains. But machines is not possible to work in the same way. They can be only narrow intelligence. Intelligent means only domain specific. For a particular domain, they can be intelligent. So I can make a smart speaker. A speaker is smart. I can make a self-driving car, but it's not possible that a self-driving car knows everything about your uncle also. Or a smart speaker is able to tell you the questions about Bollywood. Okay, so we can only go for narrow intelligence which is specific to a particular domain. It's not possible that we have a general intelligence in which it can do anything which human beings do. So if we say that we are still at this point, so artificial intelligence can be of two types, type 1 and type 2, in which narrow, general and strong, and we are still at the narrow AI. We are not even close to general AI. And strong AI is apart from even thinking that it is working more than as what human beings do. But for a particular domain, of course, we can do that. Like chess. You know that the IBM developed a chess program which was able to defeat Kasparov. So it was able to do it for a particular domain. It was able to make a chess program which worked more than the human being, but only for a particular domain, not for all the things. Even if you're making a robot will be very efficient in one domain. You must have all seen the movie Robot, Rajnikant movie. And in that, it was said that it is replicating a human being. It knows everything about how human beings do. So he was, but at the end of the day, at the end of the movie, he failed because the person gave him emotions and he was not able to handle those emotions. So human beings are much than intelligent than machines are, and we are at a very good pace in which we are doing wonderful jobs in narrow AI, domain specific. Okay, so as it says, it's neuroscience. I'll come to the last Turing machine. I wanted to discuss about the Turing test. Computer science people must be already aware of the Turing test, in which there was a curtain placed, and one side of the curtain was a human being, and on the other side of the curtain was a human being and a machine. And this was in way back in 1950s, in which we were trying to tell that okay, computers can also answer the questions in the same way as human beings do. So in that case, we were trying to make the computers as intelligent as human beings are. And suppose a person asked a question 20 plus 20, and the answer was given as 20 plus 20 as 40, and the person was not able to decide that the answer came from a human being or from a computer. So this was a Turing test. But I can go one step ahead in this and say that Okay, 20 plus 20, both were able to answer. What is the capital of USA? Both were able to answer. What was the capital of Rajasthan? Both were able to answer as Jaipur. But what if I ask a question, 2,03,456 multiplied by 6,07,023? Who will answer this question? Of course, only a computer can answer this question. So my Turing test fails because I was able to identify that the answer has come from a computer. The Turing test says that I should not be able to identify that the answer has come from a computer or a human being, isn't it? So if I'm able to identify that it came from a computer, then my Turing test has failed. So if I want to make a machine as intelligent as human beings, this is my thought. This is completely my thought, that if I want to make a machine as intelligent as human beings are, then it should not be able to answer those questions which human beings cannot answer, isn't it? So there is a very thin line. Like I'm able to give you the answers till thousands, but not 1 lakh. If I am not Shakuntala Devi, if I'm not Shakuntala Devi, I will not be able to answer the questions about 1 lakhs or 2 lakhs or so. But I would be able to maybe probably answer the question of 120 plus 240. That I can answer. Okay. So I'll directly come to this. The artificial intelligence have a lot of fields on which to work upon: deduction, reasoning, problem solving, knowledge representation, and in the same league we have machine learning also. So now let me come up with what is the difference between artificial intelligence and machine learning. So suppose this is AI, this is my AI, then this is machine learning. Machine learning is a subset of AI. Okay. Machine learning is a subset of AI. Anything what you do in machine learning is absolutely artificial intelligence. Nothing is AI, which is, there may be certain things which are AI but not ML. That is possible. But there is nothing as such which is ML and not AI. So whatever you do in machine learning, it's have to be artificially intelligent. And under it, there is another field which is known as deep learning. Deep learning is another subset of machine learning. Okay, so I have a superset of AI, artificial intelligence. A subset of that is machine learning, and another subset of that is deep learning. So let me take some questions at this point of time if you have. We'll be talking about data sciences also. So just let me know if you have any doubts or questions regarding regarding artificial intelligence. We have not started machine learning as yet, but yes, I have told you that machine learning is a subset of AI. Any questions, any doubts still here? Do let me know if you have any doubts or questions. No? No doubts? Okay. Then we come, okay, thank you. Okay, then we come up with the concept of data sciences. What is data sciences? So data sciences is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights. But the most important word that comes here is insights. Insight is the extract knowledge and insights, the inference, the decision-making power. You have come up with a very long paragraph, and now you want to find out the summary of this paragraph. How will you find out the summary? You will pick up the most most important points in that, the things which are going to make that paragraph. So you are trying to do the inferences, you're trying to take out the inference of this paragraph, you're trying to take out the inference of this complete negotiation or complete discussion. So what is the insight? Insight is the knowledge. So now we come up with the concept of saying that what is the difference between data, information, and knowledge. Data, information, and knowledge. What is the difference between all three? Data is the raw data. It's the raw data. I give you an example. Like data is like 10 apples, 1 apple, 20 apples. This is raw data. It's not making any meaning to me. 20 apples. Now, what do I do with this? It's only simple data, a raw data. What is information? Information is data which is of meaning to me. It is making some meaning to me. Information can be, I eat an apple a day. Now, this makes some sense. The data is complete because it has been added with some meaning to it. I eat an apple a day. This is information. So if you process the data, if you come up with certain meaning to the data, it becomes information. Okay. Now, what is knowledge? Knowledge is information when it is combined with the prior database, data which was already there or which is already existing, and you combine these two to come up with certain conclusions, certain inferences. So knowledge would be, I eat an apple a day is information. I eat an apple a day, and since an apple a day keeps doctors away, so there are very few chances of me getting ill. This is knowledge. What was the insight that I took out? The insight was the combination of the information. What was the information? I eat an apple a day. This is the information. It was combined with what? The famous saying that an apple a day keeps doctors away. So it was both combined together. And then we came up with the insight or the conclusion or the inference saying that since I'm eating an apple a day and since an apple a day keeps doctors away, so what was the conclusion? There are very few chances of me getting ill. So on the basis of the data and on the analysis of the data, whatever analysis you have made on the data, on the basis of that, if you are coming up with certain inferences, certain conclusions, certain insights, then that is knowledge. Correct. So you have the data, information, and knowledge. So data science basically talks about the analysis of the data, taking out that knowledge, taking out that insight from it, taking out that inference from it. For this, you need to apply certain algorithms. Either you can apply mathematical models, statistical models like mean, average, like these, or you can apply the machine learning models also onto this. Machine learning models like you apply artificial neural network, or you apply support vector machines, or you apply regression. So either you can apply mathematical model or you can apply machine learning model onto it to come up with the inferences. Okay. Data science, if it may or may not involve artificial intelligence. So data science is a separate field, I would say. Data science is a separate field. This is data science, is a separate field altogether, but it has some similarity with AI also. It has some similarity with AI also because there is some overlapping. Why? Because I can use certain functions of machine learning like this. I can use certain operations of machine learning, and I can use certain operations of deep learning also. Deep learning. So machine learning and DL will definitely reside inside AI only. What is data science? Data science is that is I'm trying to analyze the data to come up with certain inferences, certain analysis. We'll talk about there are 4 types of analysis that are done. So we are coming up with certain types of analysis, certain types of conclusions with the help of tools. Now these tools can be machine learning tools or they can be mathematical models. If I am using simple analysis of average, mean, then that is not AI. If I'm just using the mean of the data, then it is not AI. It's not AI. So it will be here. It will not be inside AI. Okay. So I have a very nice video for this. Let me play that video. And just let me know if you are able to hear that. Can you hear this video? Could you hear the video? Could you hear the audio and see the video?
Yes, madam.
Okay.
Yes, ma'am.
Now, again, another concept that is there is big data. What is big data? Let me first talk about big data also. Big data says that I have huge amount of data. In 1986, we used to only deal with floppy drives, and floppy drives was 1.4 MB. Just imagine. And now MB is nothing. In fact, when we click a pic from our mobile, it is at least somewhere about 3 MB or 4 MB. So even a picture, even a photo will not suffice into a floppy drive now. A 3 MB or a 4 MB picture cannot be there in a floppy drive. And in our days, we were used to able to store everything into a floppy drive. We had a projects into our floppy drives. But now it is not possible, because there at that time the projects was C++ projects or Java projects. It was only a code which was able to be there in a floppy drive. But now, when as the days are progressing, we have come up with exabytes. We are talking about exabytes. We have come to this part, and here I'm talking about exabytes of data. Earlier it was only 1% digital, and now we have gone to 94% digital. And these in current pandemic times, in fact, we have gone to 100% digital. Have you ever even thought of that we will be having a faculty development program online? Never, never in our lives. We had never even thought of this concept of having faculty development program online. So this is all digital. And you just imagine the amount of data that is getting transferred. I'm having a session from 11:30 to 1. So in 1.5 hours, just imagine the amount of data that is getting transferred. I'm showing you text also. I'm writing some text also. I'm showing you PPTs also. I'm showing you a video also. And all this is getting transferred to your places. Somebody is sitting in Jammu, somebody is sitting at Kanyakumari, somebody is sitting at Jaipur, and somebody is sitting at Guwahati. Everybody is able to see that, and everybody is able to access it. So see the amount of data that is getting transferred, and that is all digital data. And if suppose Harikishan sir tries to store this information, store this recording, and how do you even it would be somewhere around 2 GB or 3 GB of the recording for 1.5 hours. So 2 GB of recording for one my session. So there must be some 14 to 15 sessions, 15 into 3 GB. So 75 GB of data is getting stored. And in that 75 GB of data, suppose somebody asks, some participant comes up and says, okay, I want to see that video which Pooja ma'am displayed. So Harikishan sir will have a hard time in searching all those 75 videos, 75 GB of data in those 15 videos, and then check it at which point I was showing the video. Yeah, at which point I was showing this slide of big data. If some participant says I want to see that big data slide, so he'll have to just go back to those videos and then check it out, where is that big data. Or he can also give annotations to labels to the data, to the videos. So how much work is going to be done? And you may find a lot of many projects which are going for annotations of videos, automatic annotations of videos. Automatic annotations will be definitely on the basis of what I'm speaking and what it is visible on the slides. So it involves natural language processing. Natural language processing, that is whatever I'm saying needs to be converted digitally. Then only you can label the data. Annotations, suppose if I want to label this particular time, this time of 12:05 to 12:06 as big data. So I'll have to annotate that, and for the annotations I need to understand that what I am saying. Okay, so I need to convert that into a natural language processing and process the natural language, and then come up saying that, okay, I'm talking about big data, and now it will be annotated with big data. So much and so much of things, and big data always corresponds to a lot of things. We do the analysis onto big data and then finally come up with certain decisions. So big data involves volume of data, variety of data, veracity of data, and velocity of data. Volume, I have told you, 75 GB of data. Variety, I have a PPT, I have a text, I have a video, MPV file. So much of variety of data, and all this needs to be processed. Then velocity of data. Every second I am speaking a word. In fact, 2 or 3 words I'm speaking every second. So how many words I'm going to speak every minute, and how many words I'm going to speak in an hour. So many words are being done at every second, every minute, and all this needs to be processed. This is a velocity. At veracity, uncertainty of data. At one point of time, maybe I'm just showing you a video, and another point of time I'm discussing a PPT. At one point of time I'm having 3 words per second. At one point of time I'm having 2 words per second. So that veracity, accuracy of the data needs to be checked. So for me, I generally believe only with 3 things: volume, variety, and velocity. And in the video that I would be showing, it will have 5 V's. So it depends that how many V's would you like to consider for your big data. I believe that if you consider these 3 V's, and the rest of the 2 V's are automatically inside it: volume, variety, and velocity. So now let me come back to the video which I was trying to show you. So in this case, it is saying that big data corresponds to a huge amount of data of different variety. That is what I was trying to tell you. That is, if you have big data, then you need to apply certain very big models, because the data is huge. Then how you are going to analyze that huge data? Analyze the data and then come up with the insights and inferences. So, and nowadays, when the data is growing at such a large speed, it is always a big data only. Hardly there are things in which you will be having only an Excel sheet in which you have to analyze that Excel sheet. You will be having, even if it is an Excel sheet, it will be a very huge Excel sheet, and you will be doing some analysis, the intricate analysis of that, which may require some machine learning models to be built onto it. So nowadays, whenever we speak about data science, we speak about machine learning also, because the data is big data, and for big data analysis you need machine learning tools, analysis, or finding out the insights or inferences. Data mining is now interchangeably used with data science. In our days, we used to talk about data mining. Data mining was a very big hype word. But now we have replaced it with data science, saying that, okay, since we are working on to a very huge data, so we will be talking about data science, and it involves the visualization of data. So having proper graphs, proper tools to plot these graphs, and have bar charts, pie charts to actually analyze the data and apply the machine learning and statistical models onto it. this is a very important thing it says is they do not follow the rule based algorithms. It's not a rule based that it's if then else conditions, that if so and so happens then you do this, else you do this. Because since we are working in real world, it may happen that you have not even thought of those conditions, and those conditions do appear. In real world problems it happens always. Life doesn't go as you think of. Life always have very surprises, and many things there are in which many people say that it is uncontrollable. Life is not controllable. Life is always controlled by some hands. I believe in God, so I say God takes care of everything. So it's being handled by someone else, and you get a lot of surprises. So life cannot deal with if then else rules. If so and so happens, then you do this, else you do this. It's not possible. And when we're talking about machine learning, data sciences, then they always deal with real life problems, and real life problems will be able to do it on their own. Here comes the concept of behaving the same way as human beings do. Every time it's not possible that now when we are old enough, in fact above 18, it's not possible that you ask each and everything from your parents and then do it. You have to do it on your own. So till 18 years you were trained by your parents to do this, that, in this way, in that way, and so on. You were trained for each and everything. And in fact, you were also trained to handle some of the things. But after 18, it's not possible that you go again and again, okay, mama, this happened, what to do, this happened, what to do. You have to take your calls. And on the basis of that calls, you learn from your experiences also. So as you say, in machine learning, there are three things that are done: training, validation, and testing. So I get a good example now. Training is till 18 years of age. You are trained by your parents. You have to do this. You should not go out after 8 o'clock, or you should not have too much of my throat. I have got my throat infection, so I have been told this to be done. I am taking my kadha, I am taking my medicines, I am taking everything just to protect myself from corona. So these are the things that have been told to me. I have been trained for it, and now I am using it. But I was not trained for corona, of course. I was trained for bad throat, so I am using all those things. I am taking steam. So these were the things which were told for cold, but not for corona. But as and when the things are coming, we are getting accustomed to that. So training was done till 18 years of age, in which you were told to do and the things. Then till 18 to 21 years of age, another 4 to 5 years, you are validated. Validated means you are with your parents. You are not married. You are with your parents, and you are checked that whether you are actually using your training effectively or not. Okay, so you will be left onto your own, do your things, and if you have any problems, then you can discuss with your parents for sure. But you will be allowed to take certain actions and do the things. Okay, so you are validating your training. बोलता है ना कि पापा मम्मी ने बहुत अच्छी ट्रेनिंग दी है तभी वो इतना अच्छा काम कर रहा है, या पापा का बच्चा है वो इसीलिए वो इतने अच्छे से बिहेव कर रहा है. So that is what you were trained till 18 years of age. Then after that you are validating it, that is okay, whatever I have been given the training, I am trying to exercise it. After you get married, you are tested in the sense now you come to the actual conditions and the testing starts. Okay, so in the machine learning problems also, it's a very weird example that I've given you, but actually it is true. And in fact, whenever you are given a data, if suppose you have 100 records, in those 100 records, 80 records will be used for training and 10 records will be used for validation. If you don't have a separate test data, if you have a separate test data, then you go for 80 rows for training, 20 rows for validation, and separately you test it. You have been trained, you have been validated, the model is complete, the model is there. Now you apply it onto the real-time scenarios and check whether the training was perfect or not, and then you give up the losses, predictions, you do the predictions, and accordingly you find out your evaluations. We'll come to that also again. Let's It says neural networks takes the inspiration from our neurons. Whatever neurons we have in our brains, it takes the inspiration from there. Why? Because we want our machines to behave as human beings do. Human beings learn, train, think because of the neurons. So we want our machines also to do the same way. So that is why they take an inspiration from our neurons. This is what we discussed. Data science is a process of extracting the inferences, the conclusions, the decisions from the large volumes of data. And for this, they may need, so for this, it may involve the machine learning tools. Okay, so this is what we discussed. That is, what is big data? Big data is a huge volume of data. And I have stopped presenting. Big data is a huge volume of data, and AI is, that is, you are trying to use certain models to behave, to make the machines behave as human beings do, and machine learning is a subset of AI. Okay, and data science may involve the machine learning tools, statistical models, visualization tools to do the inferences to find out the insights. Any problems still here? Any questions still here? To let me know, please. No? If you have any questions, you can put it onto the chat box. Now we have done the introduction of data science, machine learning, AI, and big data. No? Okay. So these are the four types of analysis that are done with the help of data in data sciences using big data: descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. Descriptive analysis says that is what is actually happening, the current scenario, the present scenario, what is happening. Diagnostic, why did it happen? Why, whatever is happening currently, why is, what are the reasons for its happening? Why is it happening? Predictive, what is going to happen in the future? And prescriptive is, I know what is going to happen in the future, then what are the remedies that we can take? If it is good, then I will continue to do it. If it is bad, then I may come up with certain more things so that it doesn't happen. So what are my recommendations? What should I do so that my prescriptive analysis is as per my desire? Whatever I want is being done or not. Prescriptive analysis and predictive analysis is basically the future. Prescriptive and predictive is the future, and diagnostic and descriptive is the past. That is what is happening, past and present, you can say. So what is happening and why did it happen? Like, suppose if I give you an example of corona only. So corona says descriptive analysis is, the case of descriptive analysis is, that is, every day you are getting the numbers from the news on the newspaper, that is okay, 72,000 cases newly appeared on Wednesday, so and so. On Wednesday, there were 72,000 cases and there were 200 deaths, and so on and so forth. So this is descriptive analysis. Diagnostic analysis is people were not following the norms. People were not doing the social distancing. People went off to have a party with 100 people, and because of which the number of cases increased. That is diagnostic analysis. That is why did it happen? Why there was so much of 72,000 cases? What is the reason behind it? Are the people not taking proper precautions? Then what was the diagnostic analysis? Predictive analysis. In another 15 days, the cases are going to surge a lot. In another 15 days, probably we may get some 1 lakhs of cases instead of 72, or we may decrease the cases to 50,000 in another 10 days. That is predictive analysis. And prescriptive analysis, if it is going to be 1 lakh, then what should be done? Lockdown has to be there. This was prescriptive analysis, and all this was done in the case of e-governance also. The government took proper actions at the proper time. So that is why we were able to reduce the number of patients. And we went for a lockdown for complete 1 month. We did a lockdown. That is why the numbers were not so much as it was supposed to be, because we have 136 crore of people, 135 crore of people, 135 crores, and still we are at 0.01% or so. So if you see about the percentage, we are doing very good. But it is a problem. Corona needs to be faced. So descriptive, diagnostic, why did it happen? Descriptive, what is happening currently, what is going to happen in the future, and what are the remedial measures that we can take in the prescriptive analysis. So these all types of analysis is done with the help of machine learning models. So now we come to an introduction to machine learning. What is machine learning? Machine learning. What happened? So what exactly is machine learning? Machine learning is different from traditional programming. In the case of the traditional programming, what we do, we give the input, we give the program, and we expect the output. Now, suppose if I have written a program, I'm writing a program, IIT A, IIT B, IIT C is equal to A plus B, and C out C. Suppose this is a C++ code. If it is a C code, I would have written printf. So I may also give the values here in is equal to 20. So what is the input to the program? What was input to the program? What was input? Input was A is equal to 10, B is equal to 20, and the program itself. This program was given as an input. What was the output? Output was simply C, that is equal to 30. This was my output. I gave this program, I give this input, and I got this as an output. This is what we do traditionally. This happens in the case of traditional program. What if I write 10, 20 is equal to 30? If I ask you what should be the operator here to get 30, you will definitely say it should be a plus. It should be a plus to get 30. So what if I give only the data, this is my data, and I give you the output. So what is the input in this case? I am giving you the data, and I am giving you the output. Now I am asking you what should be the program. What should be the program to get the desired output? What is my desired output? 30. 30 is my desired output. What should be the program to get the desired output? I have given you the data. 10 and 20 is my data. 10 and 20 is my data, and I am asking you what should be the program so that I get the output. Okay, I know the output beforehand. I know what is to be done, but how? That is the question which is answered in the case of machine learning. Machine learning says, I'm giving you the data, I'm giving you the output. I'm giving you the data, I'm giving you the output. Now tell me what should be the program. And what happens in the case of traditional programming? We give the data, we give the program, and we ask you for the output. Like suppose if there is an interview and it asks you what is 11 into 11, it says 65. No, it is not 65, it is 121. It itself should learn it and say, okay, it is 121. So I have given you the output. What is the output? I have given you 121. I have given you the input 11 into 11. Now you come up with the program and give me that how to get 121. What should be the program? What should be the logic behind it to get the correct output? So we go for fine tuning of the parameters. We go for many other things so that we get the correct output. Since we all are engineers, so we always come up with a mathematical model for it. That what should be the mathematical model to do it? It requires P performance, task T, and experience E. It requires three things: P, T, and E. Performance, task, and experience. Performance, task is what is your objective? What are you supposed to do? That is your task. Performance, evaluation. Did you do your task good? Were you able to achieve accuracy? That is performance. E is my experience. It's basically the past experiences, the past knowledge. Let me give you an example for this. This is the example that we are considering. My task is to drive on a 4-lane highway. I am supposed to drive on a 4-lane highway without any accidents, using sensors, actuators, transducers, whatever. My task is basically to drive on a 4-lane highway. What is P? Would be the performance. That is how much distance I was able to travel without any accidents. Yeah, how much distance I was able to travel from the source to the destination. Have I reached the destination? This is all performance. What will be the E? The E can be the Google Maps. Okay, so E can also be the sequence of images that comes, or it can be the experiences. Like suppose I have to go from A is my source and B is the destination. And there are two paths to travel, path 1 and path 2. Path 1 took 10 minutes and path 2, and I went yesterday by path 1 and it took me 10 minutes. Today I went from path B and it took me 8 minutes. So this is my experience. Next time if I am going to travel, I will take the path B because it is taking me less time. But maybe the kilometers are more. Path A involves a lot of potholes. Path B doesn't involve any potholes. So even path A is of only 10 kilometers, it is taking me 10 minutes. But path B is 12 kilometers, but then too it is taking me 8 minutes because it is a very smooth road without any traffic, without any potholes. So I will prefer path B. But what is my criteria? What is my task? My task is less time or less kilometers. It may happen that I want to save petrol. I don't want more number of kilometers, so probably I'll take a path A. But if my task is time, I want to be on less time, I'll take a path B, whatever the petrol may be. So what is your task? The task can be, I want to travel. It can be the shortest distance, path B. Or if I want to have it the shortest distance is path A and shortest time is path B. So depending upon the task, your performance is going to change and your experience, which experience you are going to use for your machine learning model. Another is recognition of the faces. Your task is to recognize the faces. What is the performance? How many faces was I able to recognize? I was given 100 faces and out of which 80 faces I was able to recognize successfully. So my accuracy is 80%. This is my T. And what was a person? E. E was a complete database of all the faces, isn't it? And for this, I am given 6 steps. Solve any machine learning problem, we are given 6 steps. Define objective, that is the task. What is my task? Data gathering, gather the data. This is, in fact, nowadays, these two are the main problems. You don't get the solution to these two problems. Data gathering, from where to get the data. Suppose I want to check for corona detection. On the basis of kidney images or on the basis of liver images, I want to detect the corona, or I want to predict detection or prediction or whatever. So in both the cases, I don't have enough data. I don't have images. I don't have enough data to actually do the process. I want to check that on the basis of that how the COVID is happening. Again, I don't have the data. Okay, so data gathering is a big problem. Then I have the data, but it is in images. And images data is not required for my particular algorithm. Or the images are in the BMP format. I have to convert it into JPG format. Whatever. The data can be of any type, and I want to prepare the data so that it is more useful to me. Okay. For this, I'll show you an example. I have the COVID data with me. I was doing it for my research work. So I had my COVID data. So this is the COVID data which I have, which talks in terms of countries. It talks countries. It gives you the latitudes and longitudes of the countries and on which dates, what were the confirmed cases, what were the deaths, and what were the recoveries. Suppose this is the data, and this is for all the countries. First of all, I had to gather this data. So I went to kaggle.com. Kaggle.com, I'm putting it over here. It's a site for which for gathering of the data. It's a very beautiful site in which you mostly get most of the data that is required. But if you are really going to handle a new problem, probably you won't get the data on Kaggle also. So data gathering is a big problem. Fortunately, you will get this data on Kaggle, the one which I am showing you, the COVID data. Muhammad Ahmed sir is asking, repeat the insight in data science. Insight is basically the inferences, the conclusions, the decisions that I'm retrieving from the data. I'll give you an example in COVID also. So this is my COVID data. And this first of all, I gathered the data from kaggle.com. Now I have to prepare the data. Now the preparation of the data involves the data which I actually need. So do I need the data of Australia? Do I need the data of Angola? No, I don't need all this data. What I need is the data only for India. So what I'll do is I'll search for India. And this is the data which I actually need. 22nd of January, no cases. 23rd, no cases. And if I am proceeding further, now the cases have started coming. 3 cases on 7th of Feb. And for a very long time, it will be 3 cases only. For a very, very long time. 3 cases. On 20, till 26th of Feb, it is only 3 cases. Now the cases have increased on 2nd of March. Again, only 5 cases. And now it has become 30 cases on 5th of March. 31 cases. Now slowly the cases have started increasing. And my major concern would be the later point of time when the number of cases are 142 or to 156. Now the cases have started increasing. Okay. So what is data preparation? Data preparation will involve, first of all, I want to consider only the data for my country, India. So I will use Python programming do the analysis and pre-process this data. That is, it will filter the data only on India. I'll use pandas, I will use NumPy and sklearn. These are the 3 libraries which I use with pandas a lot, with Python a lot, and they are used for machine learning problems. So I'll filter the data on India. Secondly, this is redundant data, latitude and longitude. This is all coming again and again and again. I don't need this. I don't need the latitude and longitude. So I'll have to delete these 2 columns. First step was filter the data on India. Second step was remove these 2. Third was, now this field is a string format. Date is a string format. So I'll have to encode it. I have to convert it into numbers. So probably I can say 18th of March is 1, 19th of March is 2, 20th of March is 3, and so on. So this is encoding of the data. So I'll have to do some programming for the encoding of the data. Clear? Then I don't want the data for February, because for February, mostly it was only third of 3 in numbers. So it is giving me a duplicate data. So duplicate data is not required. So I'll have to remove all that, and then maybe I can start the processing from March. So till March, I'll have to remove the data. So this is all pre-processing. What is preparation of the data, basically? I'm doing the preparation of the data. Data exploration. Data exploration is visualization of this data. I may draw a plot here only between these 2 values, between confirmed cases and this, or how the cases are getting increased. I can get it in the help of data explorations. And then finally, I'll build the model. Build the model is, that is, apply any machine learning algorithm onto it. I can apply train the model. Building a model is basically training the model. So I can apply a SVM, support vector machine, or I can apply a regression model, or I can apply a decision tree, or whatever. And I will evaluate the model. This is nothing but validation. This is the validation which I was trying to tell you. This is validation. This is training. So I train the model. I train the model by applying any machine learning algorithm. I validate the model, and prediction is on the basis of that I am going to predict. Like suppose the data which I showed you is only till 24th of April. Okay, so I'll say what can be the value, what can be the number of confirmed cases on 1st of May. Yeah, what can be the number of confirmed cases on 10th of October, because 10th of October has still not come. But on the basis till 7th of October or 8th of October, I have trained my model. I have trained my model on the basis till 8th of October. And on the basis of that, I am predicting what should be the value on 10th of October. Suppose I say it would be 72,000 people, 72,000 new cases will appear on 10th of October. But actually, it was only 71,000. So I will evaluate the model. I will subtract this. I'll find out the loss function and so on. So I'll get, okay, there was an error of 1,000. What is the percentage of error and so on. So I can calculate all these things on the basis of the evaluation of the model. Yeah. So prediction is done once I have trained the model. Now, what is the inference? The inference that I have calculated is the inferences, that is the data is going on increasing at a very, very large speed. Now, earlier it was only 1 case or 2 cases, and now it has come up with 72,000 cases. This is my analysis. So any inference that I take out from my analysis, any inference that I take out from the analysis, any conclusion that I take out from the analysis is inference, the knowledge, the insight. Okay? Yes? So now let me know if you have any doubts or questions. Because it will take me another 10 to 15 minutes to discuss about the types of machine learning algorithms. I'm giving you a couple of minutes. Think over if you have any doubts or questions. That's quite strange that you don't have any doubts. Quite strange. Either you have understood everything or you have not understood anything. What is the reason? Have you understood everything? Mohammad Ahmed sir, were you able to understand now what is insight?
Yes, ma'am. I understood now.
Okay, thank you. So, any other doubts or questions? No? Okay. So then we can start with the types of machine learning algorithms. Types of machine learning algorithms are supervised, unsupervised, semi-supervised, and reinforcement learning. Basically, it is only of 3 types: supervised, semi-supervised, supervised, unsupervised, and reinforcement. Semi-supervised is nothing but a combination of these two. It's a combination of these two. Now, from the figure, it is very, it is self-explanatory that this is supervised, because there is a person who is actually teaching you. If there is a person who teaches you A, B, C, D, then there is someone to supervise you at each and every phase. You should not do this, you should do this, you should not do this. This is supervised algorithm. There is no one to teach you, there is no one to help you out, then that is unsupervised. This is unsupervised technique. This is supervised technique. Okay, so you have a proper database with you, and on the basis of that, you are deciding what should be done and what should not be done. So let me first discuss these two, and then I'll come to reinforcement. So what happens in the case of supervised learning? The data is actually annotated. The data is annotated. It says that, okay, this is Tom and this is Jain. So it is an annotated data. You know what is there. Suppose I have some data like this. This is a triangle. This is a triangle. This is a square. This is a square. This is a triangle. And this is a circle. Suppose I have this much of data. So I come up with this. I will extract the features from this. Now, what are features? Features are, it has 3 lines. It is red in color. Let me make it different color. These are the squares. This is nothing. Okay. So what are the features that I will extract? I will say, okay, red in color, and 3 sides. Why not have it in one box and term it as T? This also has 3 lines and red in color. Have it over here only and make it as T. This has 4 lines and green in color, which is very much different from this. These two are not matching because this has 4 lines that is green in color. So let's put it into a different bucket. So I put it in a different bucket and name it as square. This also have 4 lines and green in color. I put it inside in a different bucket and make it as S. Now this again has 3 lines and red in color. I'll put it in the previous bucket. I'll put it here. Here comes, it doesn't have any lines and it is red in color. Put it in a different bucket and name it as C. So what has happened? I have 3 buckets here, 1, 2, and 3. And I know the names of the buckets. I would really request you to please mute your mic. Please mute your mic.
సరే సార్ అదే సాయంత్రం
Please mute your mic. Shravanti K, can you please mute your mic? Okay. My annotations are gone now. Anyways, what I was trying to tell you was, I had now 3 buckets. I had 3 buckets in which there were 3 triangles, T, T, and T, and I named this entire bucket to be as triangle. Then I had this 2 squares, and I named the entire bucket as a square. Okay, and I had another one, this circle, and I named the entire bucket as circle. This bucket is nothing but classes, and I have named these classes as triangle, square, and circle. Okay, so this is a labeled data. I have given you proper labels, and with the help of these labels, you can identify that, okay, this is a triangle, this is a square, or this is a circle. The process will remain the same. Feature extraction would be there, comparison of the features will be there, everything would be there. Data cleaning, exploratory data analysis, algorithm, model evaluation, all the 6 phases that we discussed earlier would be there. Only difference would be that the data is labeled or not, annotated or not. Similarly, what happens in the case of unsupervised learning? I have the data, but it is not labeled. So what will happen in this case? I have these triangles. I'll put it inside one bucket. I have the squares. I put it inside one bucket. And I have the circle. And I'll put it inside one bucket. But I don't know what the names of these buckets. I'll simply say this is A, this is B, and this is C, because I don't know the names of these buckets. Since I don't know the names of these buckets, but the feature extraction, everything will remain the same. Okay, so these are known as clusters. And this is unsupervised learning. Okay, This is unsupervised learning. What happens in the case of semi-supervised is, some of the data is labeled and some of the data is not labeled. Like suppose these two are labeled, and then I have a square which is labeled and one square is not labeled. Some of the data is labeled, some of the data is not labeled. If you want to do this, this is semi-supervised. So I'll make this as one bucket, this as another bucket, and this is semi-supervised. Okay, the combination of these two. And generally, in the real world problems, we go for semi-supervised because it is not possible that we do the annotations of everything. Some of the things would be annotated and some of the things will not be annotated. Okay, so some of the things will have proper labels and some of the things will not have proper labels. So such cases are known as semi-supervised, which is a combination of supervised and unsupervised techniques. And we have certain algorithms. In the case of supervised, if the data is continuous means I have like this. For every x, there is a particular y. For every x, there is a y, then we go for regression. Every x, there is a y. Categorical data value, if suppose these are my points, and I take this as one, I take this as one. The Tom and Jerry example, the circle and triangle example, these are all classification problems because it is not a continuous variable. I have these squares, I have these triangles, and I need to put it inside different buckets. This is classification problem. And if it is a continuous variable, it is a regression problem. And then we can apply any regression technique or classification technique. Decision forest, random forest, SVM, these are all classification techniques. Okay, decision trees is a classification technique. Random forest is a classification technique because we talk about those values which are not in a continuous variable. And in the case of unsupervised techniques, unsupervised can be clustering techniques, k-means, hierarchical model, density based. Association techniques is a priori, AICTE, FP growth. These are all unsupervised learning techniques. K-means and hierarchical are completely unsupervised, but there is SVM. SVM support vector machines. This is a semi-supervised learning technique, which involves both types of data, annotated data and non-annotated data. So it's an SVM technique. Okay. Next, we come to the third problem, which is the reinforcement learning. This reinforcement learning. What happens in this case is we don't have any database. You have nothing prior. In the case of supervised, you had the data. Unsupervised also, you had the data, labeled or not labeled. But in this case, you don't have anything. As a small child does something. You scold him. He will not do it again. He gets good marks in his English paper. They said, okay, very good. I'll give you a toffee for this, a chocolate for this. He'll repeat it again. He'll try to get the same similar marks in the next paper so that you give him a chocolate. You give him a reward. If he does good, you give him a reward. If he doesn't do good, you give him a penalty. That is, you shout at him, you scold him. Okay. If he put his hand in the socket, you scold him. Okay, you should not do this again. The kid is not going to do it again. So this is known as reinforcement learning. You don't have anything a priori, and as and when the day proceeds, you do the things as per the reward or penalty. If you get something, then that is a reward, and if you do something wrong, then you get a penalty for it. Like I give you an example like this. So there is a reinforcement agent which interacts with the environment, get an observation from the environment. If the observation, and you perform certain action on the basis of the observation. If the action is good, you will get a reward. If not, then you will get a penalty. And accordingly, you will modify your action. So it will always have a human expert. It will always have a human expert who would be giving you the feedback, whether it is good or bad, for the initial days. For initial days, when it becomes accustomed, then probably you may remove the feedback. But for the starting, you will always have a human expert who would be giving you the response. This is a response. You query it and you get a response. So you'll always get a response. You perceive something from the environment and you perform an action. And on the basis of the action, you will get a response. And on the basis of the response, you are going to change your action. As I told you, that is, if you do a thing good, you will get a reward. If you don't do it good, you will get a penalty for it. So you always need a feedback from the environment. Management. You do it for the first time, because at the first time you broke a bottle, the next time you will not do it. So you don't have anything prior, you don't have any database from beforehand. As and when you perform your tasks, your database gets ready. In fact, you must have seen Ravan movie of Shah Rukh Khan. So that was, he was trained earlier, but then he was also training himself. And that is why he became devastating, because he was training himself. He was moving away from the game. That was reinforcement learning. That is, you are training out of what has not been taught to you. Okay. And you are learning from the environment, at how the environment is working, and you are getting a feedback for it, and then actually you are training yourself again and again and again and again. So reinforcement learning is generally used in games, in which you need to train yourselves, and you come with the certain scenarios. So it is currently being used mostly in games and not in the real world scenarios, because as what I told you, it should be very calculative. Clustering techniques came in the second session, post lunch session. You would be taught one supervised learning technique and one unsupervised learning technique, so that you get a feel that what is supervised and what is unsupervised. But K means clustering and KNN. So these are the two supervised and unsupervised techniques that would be covered post lunch. So I just tried to give you an introduction to what is AI, what is data science, what is machine learning, what is AI, and why do we need all these, and what is the relationship between all. What is the relationship between AI, data science, deep learning, ML? What are the different models of machine learning? What are the different types, supervised and unsupervised, and how they are actually used? Now we have the question answer session. You let me know if you have any doubts or questions, if you want any topic to be repeated. You can unmute your mic also, or if you want, you can put it onto the chat box, whichever thing suits you. If you want, you can unmute your mic and you can ask your questions. I'm sharing my email ID. I'm currently working in many machine learning problems. And you can shoot a mail if you have any research problem to be discussed, or you want any questions to be answered, or any topic was not understood, anything that was not understood, or you were confused on any of the topics. You just let me know. I'll be happy to answer your email. You shoot a mail at this email ID. Or if you want any problem to be discussed, a research problem, let me know. I would be really happy to answer that. Any doubts, any questions? Good to see you, Harikishan sir. It's nice that Corona has given this opportunity to meet so many people across the country. Otherwise, it would not have been possible to meet you. And it's so nice that I am able to see you and meet you. And maybe in the due course of time in the future, we meet physically also. Either you come here or I come to your place, whatever. I would really be very happy to meet you physically also now. I hope the session was good and you were able to understand the things. I'm really having a very bad throat. Sorry for that.
Yeah. Okay, madam. Thank you. Really wonderful session, madam. And we will meet after post lunch session. Okay.
Yes.
So yeah, participants, if at all, if you have any questions or any queries, you can ask. Otherwise, we'll end the session and we will meet after lunch. Okay, madam. Then we'll meet afternoon. Thank you, madam, once again.
Thank you, sir. Thank you so much. Thank you.
I'm ending the session now, right?
Sure. Okay. Thank you, Rajban, sir.